Good afternoon. I am Belaid Moz, professor of physics, but I have no equations, nothing to show you. But the talk before me was about stress, and imagine the stress I had. Okay, so what am I going to talk to you about today? Today, I'll talk to you about starting. Start small, but start. It's a story about close to my heart, about a station in Beltsville, Maryland, doing climate observing stations. So earlier we had a geography talk about Anthropocene. So I'll take you back 20,000 years. Ice Age, a very nice sweet spot where we all lived for about 10,000. And the last century, you see it warming. Okay? Now, that's in the news. And you just heard last week that the Nobel Prize was given to atmospheric physics, to a couple of guys who modeled how the atmosphere was changing. And the change is 0.1 degrees centigrade in a decade. But over a century and a half, it's about 1.5. So which way are we going? That's where the debate occurs. So, and if you've been watching your news, ices are melting, floods, hurricanes, you've seen all of that. And even the nighttime on September 22 this year, it was a climate night. Lots of climate talk. And everyone has an opinion. I'm not going to talk about those opinions. But I'm going to choose two things. One, the grid it takes to measure that 0.1 in 10 years. And number one, to remind you, there is a station in Maryland that's going through everything to measure that accurately. 0.1 is at the surface. 0.1 degrees C is at the surface in a decade. So per year is 0.01. And you have to do this globally, and you have to be consistent, and you have to do it through the entire atmosphere, all 40 kilometers of it. The easiest thing is the simplest. Put a thermometer on a balloon and release it. And that's what we do. And that is the best measurement that we have. However, there are many vendors and many errors. Some vendors want to maximize profit. So as you measure your temperature, your humidity, you get a lot of data. So I show you the curves that you see is relative humidity of 5 vendors. All those students that you see are undergrad interns. We put this on a balloon, 5 different vendors. They give you so many different data sets. Which one do you believe? And I told you you're looking for 0.1 degree in a decade. So you have to check for accuracy and precision. And unfortunately, in 2006, many of them were not that good. So you have to define sensor quality performance, standardize everything. Many countries, many vendors, many errors. We say buy American, buy Russian, buy Chinese, buy Indian. Look at those colors. Those are all nationalism playing havoc on the data. So you need to go through every instrument and try to see anchor data sets. Okay? Well, you can use the best station. The Lindenberg, Germany, have done it for almost 100 years. But unfortunately, there are different managers buying different instruments. This is the trend at 8 kilometers. You see the curve is jumping up and up. It's not change, it's instrument introduced. Well, so what do we do? Now you have to do this from the surface all the way up, which means, I show you in here the box and whiskers error bars. Those are from actual measurements that we think are correct. Models, satellites are all over. But at the surface, that star is that 0.1 degree that you see, and you did notice it. Up high, it's cold. When you're hot at the bottom, you try to ventilate at the top. That's Earth's physics explains it. Okay, so do we keep going with different sensors, or do we tell the companies to shape up? So in 2008, this Global Climate Observing Reference Station came into being. It's called GRU-1. And the idea is, do not accept black boxes, do not accept proprietary software, do not accept, disregard any systematic effects. So just make sure transparent, uncertainty defined, and make it traceable. It's an interesting idea. And that is what the UN under the Weather Meteorological Organization, WMO, started doing. And there's only one station that's operated by a university, and it's in Beltsville in Maryland, who operated through collaboration with Howard University. Dean Moffitt, that's your place. And imagine, it takes about 4 hours to send this balloon all the way through. So every week, between 1 and 5 a.m., there is a student launching this and waiting there. For 13 years, 52 weeks a year, and counting, okay? Start small, but start anyway. So I showed you the graph from 2006, and I show you 10 years later. At the bottom, you see how all those vendors match. So if you show them their error, they will correct it. But what makes me happy is when I show you that picture in the middle. Every student there is a PhD now. So that is close to my heart. And of course, I lead NASA centers. And of course, there are many satellite fleets over there measuring globally. Again, many vendors, many satellites, many countries, you got it. And Beltsville is the designated calibration site. So, when I hear a lot of those talks, opinions, there's one poor scientist measuring and making you watch. Thank you very much.